Okay, hello guys. Today we're talking about the probability and statistics one, okay? It's our first lesson on the probability, okay? Let's move into the first part about the probability scale and the single event, okay? So first, what is a probability scale? You can find here in my graph, giving axis, okay? So you'll find from 0, that means impossible, and certain means 1 or also be considered as 100%, right? Okay? So maybe the event will happening for a half chance, so we can say it's 0.5 or a half, okay? That is a probability scale. So because probabilities can be written down as fractions, decimals, and percentage. Any of them can be written as this way, okay? So here, you should never write down the percentage or probability as a ratio. Like here, you cannot say 1 versus, that is not true, okay? That is not a probability, okay? So here we can say, what is a probability? So here is a definite for the probability. That is the probability of event happening equals to the number of the successful outcomes over the total number of possible outcomes. Okay. So for example, like you are playing a game, you want to drag a card from maybe for A's, 2, 3, and 4. Okay. Maybe you want to drag a card from the poker card, and you cannot see the exact number on this. That is because they're reverse to their back. Okay, so here once you drag the card, you want to get an ace. So that means there's only one event for you to get the ace, right? But also, if you draw a card, you have maybe other choices like you have drag a 2, 3, and 4 or an ace, right? Okay, that is it. So because total probability here equals to 4, right? Or total number of events here equals to 4, and the successful outcome is 1. So the probability of you dragging an ace is 1 over 4, or you can also say it's 25%, right? Okay, so here is also another example like here. Rolling a fair standard six-sided dice, and we can say here the total possible outcomes here is 6, right? The number we have is 1, 2, 3, 4, 5, 6, right? And for the probability of rolling a 4, we can say that here there's only one successful outcome, right? So the uh here is 1 and the denominator here is for the 6, right? So here we can say probability here is for 1 over 6, okay? So here you can also say like the probability if you want to roll in an even number, that we have 2, 4, 6, right? So the number of successful outcomes here is 3, right? Here is 3, and the total number of possible outcomes is 6. So here is for 3 over 6. Or you can also say it's a half, okay? So we also have the single event right here. We can code when you're using a spinner. Here you can find a spinner, right? So here we have 5 areas. Like first we have 2 regions for red, 2 regions for blue, and 1 region for green. Okay, so if you want to set, you want to spine it, and the probability of your spining to a red, that means the number of events that's successful, right? That is only 2 areas for us, right? And total area or region for the colors, there are 5, right? So here probability is 2 over 5. And also for blue, here is 2 blue areas, right? So we can say here is also 2. 2 over the total number of the event, that is 5, that is 2 over 5. And for probability to spike to the green, that is 1 over 5, okay? So that is how we can get our event right here, okay? Also, we said here we have a complementary event. That means notable, okay? So we can say when event happens after this event does not happen, the total possibility here equals to 1, okay? So we can also using this symbol to represent for A. So here, not event for A equals to 1 minus the possibility for A, okay? So here's an example, like here, if the probability of the rain tomorrow is for 0.15, and what is the probability that it will not rain, okay? So we can say that total possibility here is 1, and we have to minus the event happening that is 0.15, right? And finally, the event probability is 0.85, right? So the probability for no rain is for 0.85. That is a complementary event right here, okay? Sorry for that, okay? So here we also have a exclusive event like here. For example, like the rolling a 2 and rolling a 5 on a single dice, right? Okay. Or like here, drawing a heart and drawing a spade on a single card draw, right? Okay. So we can say this event does not have relationship with other event, right? There are two independent events for each other. So we can say here, like when you're said P a or B, that maybe A will happen or B will happen, then we can write it as probability for A added with probability for B, right? Because it's a total probability for two events happening either, right? So for example, like here, we have a six fair dice, right? And here we have to find the possibility for us to roll in a two or five. So here, rolling two is 1/6, right? Because here is only one outcome. And for total dice is here is for six, that is 1/6. And for us to roll in a five, because the probability here is 1/6. So here, adding together, the probability equals to 2/6, or we can also say is 1/3 right here, right? Okay. And here, there's a developer practice for us to solving problem. So let's move to the first problem together. But you want to solve on yourself, you can pause the video and do it yourself. But you want to follow with me, you can keep on going, okay? So let's move to the first problem here. Is that a bag contains 4 red, blue, 5, and 3 yellow marbles, right? And the marble is chosen at random and find probability for yellow chosen, right? So here we can say, because we are chosen yellow, there's only 3 kind of event for successful event, right? And we can say here, the marble chosen is for 4 plus 5 plus 3, that is total number of events, right? So here, possibility can be written as 3 over, here 4 plus 5 is 9, 9 plus 3 is 12, right? So here is for 3 over 12, that is for 1/4, okay? That is a possibility for yellow marble, okay? And for second problem is that using the same bag, find the probability of selecting a marble that is not blue, right? So here we can say because here we have 4 red, 5 blue, and 3 yellow. So you can say that not blue, we have red or yellow, right? So for the red, the possibility here is for 3/12, right? Oh, sorry, 4/12, right? And for yellow here, we can say is for 3/12. So total possibility here is 7/12. Also, you can just first written down the possibility for dragging a blue marble, right? So for P blue, we can say it's for 5/12, right? And then you can using the total possibility to minus the exclusive event. So that is 1 minus 5/12 is for 7/12, right? That is for second problem. And for the third problem right here is that the probability that a bus arrives late is 2/11. What is the probability that it arrives on time, right? So because arriving on time is using the total number of event, y1 minus here is 2/11, right? That is for 9/11. So here is for the total probability right here, okay? That is it. And the last problem is that a letter is chosen from the word mathematics and find the probability that the letter is A, E, I, O, U, right? A vowel. Okay. So here we can find here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? We have total number of letters for 11, right? And for A, I, O, U, because here first we have an A, we have an E, we have another A, we have another I, right? We have 4 vowel here. So we can say here using the possibilities formula that is for number of event in condition over the total number of event, right? That is 4/11. So we can calculate as our final answer, 4/11. Okay, that is it. That is how we can choose it from the random from the word mathematics. Okay, that is it. Okay, so here's for today's our lesson, how we can understand if we're how to calculate the probability just using the number of event in condition or number of event in the successful event over the total number of event. Okay, they're quite important for you to master all of them. Okay, so that's for today's our lesson. See you next time. Bye.